My name is Alexander Korotkov, and today I will have a talk about future of Postgres table access methods. Today I'm speaking remotely. It's a shame I didn't came Canada, but after COVID, Canada have so huge backlog of visa applications, and I didn't do my visa in time. So sorry for speaking remotely, but hopefully I will still manage to do my talk properly. And I will start with an introduction of the current situation with table access methods in Postgres. Initially, Postgres came with built-in table access method. It came with a heap. So even despite Postgres was designed to be as much extendable as possible, but table access method was missing piece of puzzle for a very long time. But finally, pluggable table access methods were introduced into Postgres 12. It was a significant piece of work, mostly contributed by Andres Freund. I think that was a great job because it was not only about wrapping some methods into API, but a big amount of work about abstraction for particular tuple format. So there are large commits implementing so-called slotification. So replacements of passing tuples in particular heap tuple format with abstract table tuple slot. But even despite that efforts, currently we can see any full functional transactional table access methods, a new table access methods which could fit to this API. We had a project of that heap, and initial work with table access method was connected to that heap, but even that heap came with a patch to table access method code. This table access method API still need works to have some examples of proper new table access methods, which shows significant new facilities for users. I'm a designer for OrioleDB, a new table access method which currently carries this flag. And OrioleDB does things very differently from what Postgres heap currently does. Postgres heap stores the raw version in a flat manner, but OrioleDB implements undo lock. Postgres heap implements rows in the rows identified by the CTIDs, by their physical places on the pages. But in OrioleDB, OrioleDB implements index organizer tables where rows are identified by their primary case. And in order to do all of these changes, OrioleDB have to also patch the Postgres core code. And the goal of my talk is to highlight some key API improvements that OrioleDB needs to implement everything in DAS, but also I believe that other table access methods, the future table access methods, would also need these changes. So this is not just specific changes for specific projects, but these are general improvements for Postgres extensibility, which we need to really have a full power of table access methods to let them do more work. And I will show some code fragments on the slides, but please don't expect them to be full patches. For sure, if the slide shows some API change, that also comes with a lot of associated code changes, which I can't show just on the slides because of volume, but all the patches are already on our GitHub, and they will be in next few days. I will bring them to the hackers mailing list. Okay, here is a list of table access method improvements, and let me start considering them one by one. The first very important patch addresses row ID issue. So currently, every row must be identified by CTID. So CTID in Postgres is a reference to a particular physical tuple location. It's 32 bits block number and 16 bits offset number. Unfortunately, some code passes still assume that even row version, even particular tuples should be identified by CTID. So that means that different versions should have different CTIDs, which for sure isn't a good idea if your table access method is doing is implementing undo lock. But even if you eliminate this, then still CTID is a limitation if you are going to implement index organized table, because your index organized table could be at very easiest case 64-bit integer, and that integer couldn't fit to 48 bits of CTID. And that's really a showstopper for index organized tables, and we need to improve our APIs in this way. So at first, this patch introduces a new enum row reference type, which gives an option which you have, which relation have to identify its rows. So the first option is CTID. The next option is a new one introduced in the patch is row ID. So row ID here is just custom byte array field. So it's an array of arbitrary number of bytes, and in principle it could represent any kind of row ID, right? So you can encode anything in a sequence of bytes. It could be index organized table on a single field, on multiple fields. You can always encode this as byte A. And another row ref copy, it's actually already used by foreign data wrappers. And we just bring it here to this enum. And in foreign data wrappers currently, to identify the row, we use a full copy of this row because we don't know how the remote resource identify that. And in table IAM routine, in the routine which contains all the function pointers which implements particular table access method, we add a new method getRowRefType, which identifies what is the row reference type for a particular relation. So new table IAM routine may say that all my tables is identified by byte array row ID, or it could be different answers for different relations. And then we also have to change all the tuple IDs, which we pass to methods like tuple delete, tuple update, tuple log with datums. So it's not item pointers, because item pointers means that that would be cited, but now it's abstract datum tuple IDs, and all the code in modified table node in the patch is changed accordingly to correctly handle different type of row IDs. And another not so evident part that tuple insert, which inserts new tuple, should also return the new slot for just inserted tuple, because when you insert into a partitioning table or a table with inheritance, then it might happen that tuple insert could just insert a virtual table slot. And then it's important to return the slot which could correctly calculate the row ID. And as a summary, we can get, with this patch, we can have an abstract row ID which could potentially hold anything. But important thing is that we have bitmap scans, and these bitmap scans are heavily dependent on particular physical implementation of CTID. And bitmap scans for the tables which use row ID should be replaced or disabled. Currently in OreolDB, we are replacing bitmap scans passes using hooks, but during further works on this patch, we probably need to have a proper API for that and don't use hooks for that. Okay, then next patch reworks insert on conflict. On this slide, you can see how currently table access method API works with insert on conflict. And this actually consists of two methods. One of them insert, so-called speculative token. So this is basically some virtual CTID that you can use to insert to indexes. And another is completes usage of this token. And I think this is not an example of good API. This is very implementation dependent. So it not encapsulates much, but it's actually represent how this is done for heap. Because imagine you are doing upsert into an index organized table using the key, which is used to organize actually this table. So this is simple. You are just finding the place for your row in the tree, and then you can see if it's already present, then you update. If it's not present, then you insert. But you don't need to bother with speculative token and so on. So this API doesn't leave table access method with enough freedom to implement upsert in the most efficient way it could do. Instead of this, what we propose is to implement a new method, tuple insert with arbiter. The idea of this method is that it method tries to insert a new tuple into the table, and this method accepts a list of arbiter indexes. So the indexes which are used for a key for upsert, right? So insert of conflict have also clause which describes conflict on which columns or conflict on which index, and finally the modify node turns it into a list of indexes, and that list of indexes we pass into tuple insert with arbiter. And what this method does, it is inserts if there is no conflict, but if there is conflict, it locks the row because it's given with a lock mode and a slot to place the locked tuple. And if it did successfully lock the tuple, then the caller, the modify node, knows that we definitely have a conflict, and we just need to go and update this tuple or do other actions as specified in insert on conflict. And this API leaves stable access method with enough of freedom on how to do the absurd. So if its index organizes a table and conflicting keys match the primary key, then you can just go, you just traverse the tree and you just find the place for this the new tuple. And if you see a conflicting tuple, you could immediately lock it. If you don't see the conflicting tuple, then you immediately insert this. Very simple, no retry loops and no other bothering things. But this patch have currently it have some place for improvements, definitely, because it currently passes the executor state to the table access method, and this is probably not the proper way to do the things, and we need user works to work around this. Okay, I have also faced another problem. There is this method which checks. It used for checks to understand whether we need to trigger foreign key, whether need to run foreign key triggers, and it needs to check whether this tuple was created during current transaction. And how it implements this, it fetches xmin from the slot and compares this xmin with current transaction. But imagine you have undo lock. You implement in your table access method, you implement in VCC using undo lock. And then you could not always have xmin for your tuple. And this is not necessary work. And this is much implementation dependent. And the simple way to work around this is to just have a dedicated method to do this work, to just check whether this tuple in this slot belonging to this relation is created in current transaction. And then the code in this checking function becomes very simple and clean. Okay. Another thing we did is a custom analyze table. It basically just instead of calling some fixing function for sample analyze rows and fixed method for calculating total pages on the relation, instead it gathers this information from table access method using some dedicated method. So I think this is just must have, because different table access method may have very different types to analyze the table, different types, different ways to sample the data and provide the statistics. Okay, let's move further. Another set of patches brings more control on how we use indexes in table access methods. If we have existing methods, tuple update and tuple delete already have these parameter insert indexes. So this is a flag. They can say whether they will need executor to insert new index tuples to the indexes. But we could also have these parameters in insert methods, and thanks to this, if we have this, then our table access method may decide what is actual work they will do with indexes. So because imagine we have our B3 currently also heavily depends on how heap works. Our index access method also heavily depends on how our heap works, because they accept CTID. They assume that rows are identified by CTID and so on. But if we have this parameter, then we can skip the executor work on using index access method API, and table access method can do its own work with its own implementation of indexes and skip what executor will does for them. And if the table access method have their own implementations for indexes, like OreolDB does, then it also needs to get the information of index definition. So when the new index is defined, we also need this callback to be able to make table access method be able to do its own work on building its own indexes, its own implementation of indexes. Okay. Another thing, I probably already have seen this patch. This is a missing part because currently table access method doesn't have a way to specify its own relation options. So this relation options which you specify in the with clause of your DDL, right? So this is definitely not fair because even index access method can specify its own rel options, and even op classes have their options, but table access methods doesn't. And for sure, we need rel options for table access method. But another thing is that if table access methods have own implementation of indexes, then it needs a callback to override which options the indexes have, because it might have more options. Okay, good. And the last patch I would like to consider in this talk is I'm cache. So currently, any relation have RD I'm cache field, which is a custom cache, which is dependent on index access method or table access method. And the code assumes that it should be single memory chunks allocated with a single call of palloc. And then when executor needs, it might free this chunk in single P3. But this also seems too much restrictive because your table access method might need a complex cache, not just a single chunk of memory, but complex structure with pointers, multiple allocated chunks, and so on. And in order to do this, we implement a new method free RDM cache, and this method frees the cache for given relation. And every time when executor thinks it needs to clean up the cache for particular relation, instead of just p3 of RDM cache, it calls this method, right? This custom free method, and it allows to use complex data structures in cache. Actually, just anything which a table access method will decide. Okay, please stay tuned. We are planning to have OrioleDB beta release in next few days, and the patch set I have described today will be published on PGSQL Hackers mailing list, and the patches I have considered on the slides. This is not a complete set of patches, but this is some very important patches I want to discuss and to show. And all of for sure all of them have very different complexity. For instance, row ID patch, I show only some key changes on the slides, but this is actually a very big and complex patch because it changes things for node modified table. It changes things in the trigger because we need to properly serialize this new row ID and properly deserialize and call the triggers and so on. And some pieces for this are still missing, and we will need to work on this. But in the same time, some patches are pretty simple. For instance, tuple is current is a very simple patch. Free RDM cache is a pretty simple patch. So they all have a different complexity and have a different time we need to bring them into committable shape. And I invite everybody to come and collaborate on this work. At first, because this will help OrioleDB to become pure extension for Postgres and be an alternative to heap and to resolve many of Postgres heap problems. But another reason to collaborate on improvements for table access method API is that other table access methods will also benefit. As you can see, this is a pretty generic improvements. This is not they are not much specific to what OrioleDB does. For instance, a patch for tuple insert with arbiter. This I just give you an example how this could work if you have index organized table, but it may be any different methods you want to implement upsert, probably for LSM or something else. And I'm sure that this abstraction layer give future table access method and enough freedom to implement what they want to do. For now, that's all. Thank you very much for attention, and I think I leave enough of time for the discussion, and I will be very glad to answer any questions. And special thanks for Robert, or special thanks for Chris for technical assistance for this talk. Okay.
So okay, yeah, apologies. Sorry. So any questions? Go ahead.
On the speculative insert, where you're putting in a list of indexes to check against, do you have any performance problems in that you have to probe for each tuple given the API that you're proposing, as opposed to doing a scan of all the tuples at
Okay, I'm going to try to repeat that, and if I miss something, please correct me, and I will. So the question is about speculative inserts, where you have a list of indexes to check the tuple against. And the question is about, do you have performance problems? Do you have performance implications of, what was the last part?
Having to probe each tuple separately?
Having to, whether there's a performance implication of having to probe each tuple separately.
Probe each tuple separately. So I probably didn't yet get the question because currently all the you mean probe all the inserted tuples separately or probe all index tuples separately? Because currently the node modify table or any way it let me find the relevant slide. So currently node modify table anyway process all the tuples to be inserted one by one. So it one by one will insert the speculative token, and one by one it will complete the speculative token. So I think it's anyway process this one by one. Please correct me if this is wrong. So actually this method just encapsulates this logic as well. So you can I will publish the patches, and you will see on the mailing list, and you will see that how it changes the heap code is pretty straightforward. So it saves the same logic for heap, and it didn't change much for heap, but it leaves other table access method a freedom to implement this in a different way. So I hope I did answer the question, but please ask again if you need a clarification.
He gave a thumbs up, so. Next question. I'll go with.
Yes, I have a similar question for the seated patch.
For the which?
I think ZStore also wanted a generic seated, so that's exciting to see. I was curious to know whether on platforms with smaller datas, whether you see any performance regression moving from the 48-bit item pointer down to the 32 passbar.
Okay, again, I'll try to repeat this. I may miss some pieces, so might have to come back on it. So first of all, he was saying it's really exciting to see the idea of a generic tuple ID, because that's something that we need, that other ones are definitely going to need. But then the question was if there's been a performance regression in any systems for going from the 48-bit down to the 32-bit, was that right?
Yeah,
for smaller data pieces, if there are any regressions or performance regressions on that.
I don't see. I don't expect there should be measurable performance regression for access methods which still need CTs, right? Because all of we add is for them is just some branches in node modified table, some if branches, right, which executes the relevant code for CTs, and table access method amplification is basically doing basically the same for CT and receives them in the same way as before. And given that tuple insertion and tuple modification is relatively heavy tasks in comparison with the single if branching, I don't expect there could be any measurable aggression for existing table access methods. But I think this is worth investigation. All of these patches, we need to carefully test them, check if they cause any regression. But for this particular piece, I don't expect this because we don't change tuple ID. We don't change existing CTID with byte array, right? We just implement byte array as an alternative, and how CTIDs works for heap, it will be the same. So I don't think there will be something measurable. But yes, I expect the Postgres community to help with benchmarking and finding all the potential regression we can.
All right, next question. Yeah, next question. I guess I'll go next.
About this new type of tuple, does it mean that you can access the same rows both using old and new tuple, or is it just that depending on table you must use one or the other?
So the question is, with this new type of tuple ID, is it possible to access the same row using both old and new formats, or is it necessary that each table can only go through one old or new format, but not both?
Yes, each table should have its format. So basically, we have these three types of row reference. Two of them was existing, TID and copy, which used for FDV, and row ID is a new one. And table access method should give some exact answer for particular relation, how this particular relation identifies its rows. So for heap for existing heap access method, it would be this new method will just always return row ref TID. For OrioleDB, it would be always return row ID. But there might be another table access method which could decide which type of row reference type to use, depends on whatever.
So does this mean that you have to
Okay,
modify?
did I answer?
Does this mean that you have to modify all index access methods to use also the new row index if you want to use these indexes?
So the question was, does this mean then that you have to modify all index access methods to use these different types of row IDs if you're going to use them with a table like, for example, Oriole, for example?
Yes, that's a good question. Actually, that's a separate and probably complicated topic, which I didn't cover. Exactly. So currently, index access method assumes that rows are identified by TIDs, and in index tuples, they have to reference rows by TIDs. Yes, that's it. And what we do in OrioleDB is that basically we shadow the existing table index access methods. So OrioleDB have its own implementation for B3, which implements things in many aspects differently. So it's not only about the row ID, right? But it's also about skipping using a Postgres buffer manager and using more efficient things. And it does write ahead logging in a different way and many things like this. So OrioleDB have its own B3, and it's very, very different from Postgres B3. But it actually replaces the Postgres B3 with OrioleDB using hooks. But that's a solution which works for today. But this is definitely not the way we need for the future, and that's a different topic. What we probably need is to actually split. This is just my opinion. This is not. I think this is not not yet discussed in the mailing list or something like this. This is just my opinion that we should probably split index access method entity into two entities. One entity will just hold the general notion, right? One entity will be just B3 as an idea, and this B3 as an idea will have associated op classes, right? Because op classes doesn't depend on particular way we implement B3, because op class just holds a particular comparison function and operators and so on. But there will be another new entity with access method implementation, index access method implementation, and that could be there could be different implementation for B3, and in this new entity you will have a built-in Postgres B3, which will probably continue to work with just TITs, and also it could have another implementation for B3. It would be OreolDB B3, and this OreolDB B3 will works with row ID and works with TITs, and they have a different APIs. So built-in B3 will still have an API which works with heap, but to work with OreolDB, there will be different API, because we have to implement MVCC differently, and we handle updates differently to bitrate amplification and so on. But that's another possible redesign we will probably do, and I think that just deserves a separate talk, right? So now I would like to do the some changes in an incremental manner. If we can allow row ID for table access method, if even that would require table access method to redefine indexes in a tricky way, or probably it would require table access method with row ID to don't have indexes for current state. But let's do this incrementally, step by step, and then we will go to the future. Okay.
I'll go with you in the black shirt first, and then you in the blue shirt. So
with OreolDB,
okay. Chris, can you hear me? Any other questions?
Yes, there are two more questions. I'm just listening to it, and I'll relay. Go ahead.
Right. Yeah, with OreolDB, is are the index organized tables opt-in, or is that the only way to use it? What I mean is, with OreolDB, can you use heap organized tables at all?
So his question is OreolDB solely index-oriented tables, or is it possible to have a heap-oriented OreolDB table?
Mm-hmm. Yes, OreolDB currently it's index organized table, and it's in the design of OreolDB because what we did is we decouple MVCC for primary key and for secondary keys. Okay, we decouple its MVCC. They have separate MVCC. All of them are versioned, and they are just connected with logical references. So if you define no primary key on the table, then OreolDB actually will still create a B3 with surrogate, its own internal surrogate key, but it will be still index organized table. That's it.
Yeah. Go ahead.
Well, I'm thinking about what he just said.
Okay.
Okay. Any other questions?
Yes. One second. Go ahead if you have one still.
So I'm thinking about his row type inside the table, and whether he's using, it sounds like he's not using heap formatted tuples, but rather some Oriole formatted tuples. And he doesn't want to use CTID, but I'm assuming internally he wouldn't be storing CTIDs anyway, he'd be storing something else. And then when they come through the table access method, they would be calling get heap tuple rather than, or they'd be calling copy heap tuple because get heap tuple would be null. And at that point, why can't he convert the internal tuple identifier to a kind of fake CTID and return that rather than having the rest of the system change?
So the question is that that basically he's assuming that you're using some custom tuple format, not of course the heap tuple format, and that let's see, that what are the APIs that you were saying would have to be called?
You tell me if I'm wrong. I'm assuming that get heap tuple is null and that copy heap tuple is the one he implements.
So he says he's assuming that get heap tuple would be null and copy heap tuple would be the one you'd implement. And then
if so, he's transforming his internal tuple format to heap tuple format in order to return it.
And if so, does that would mean that you'd have to return, you'd have to transform your internal heap tuple format into your internal tuple format into heap tuple format in order to return it.
And I'm wondering why you can't convert to CTID at the same time.
And he's wondering why it would be difficult to convert to CTID at the same time.
Yes, I'm not sure if I get the question, but I will try to answer. What Andres Freund did for Postgres 12, one of those things was to slotify the interface for implementing table access method API, and that allows you to have. And that means that executors deals with table access method using abstract tuple table slots, right? So it's dealing with slots without knowing its format. But that's right that at some point executor might just serialize your tuples in certain format. For instance, in heap tuples, if you have some sort node or serialized node or whatever, then it will just serialize your tuples in its own format. But what we did for row ID patch is that we add a distinct system column for row ID. So it becomes a distinct system column, and abstract tuple table slots have a separate method, slot gets system attribute, right? And our implement depending on what your slot can do, in slot get system attribute, you implement either to get your slot is able to return seed, or your slot is able to return row ID. But you should notice that either seed or row ID, if they are not, they could be used in different ways. So it could be used by node modify table, right, to identify the row you need, for instance, to update. So the first you select this row, and then node modify tables need this system column to update the required row. This is one use case, but this use case doesn't imply any serialization. So you find row, you check the conditions, and you know this is the row you want to update. Okay. But another way is that you probably need to serialize the things. But then if your TID or row ID wasn't queried explicitly by users, then you don't need them. So if you running some, complex query with some ordering and so on, then if user don't query this information, then you don't need. But if user did query this system column, they all will be anyway. There will be projection, and that projection anyway will turn your tuple into something different. And if you have some sort node, then it will just serialize this as a minimal tuple, and that will be a different minimal tuples from what you have in the table. I don't know. So I speak a lot, so I probably something of what I said did answers this for you.
All right, thank you very much. This was a great talk.
Yes, and Chris, thank you very much for assisting me. Speaking remote is quite difficult for me because I don't see the room. I don't know how they receive my talk. But so this is why I probably wasn't very confident while speaking. But the questions was very good, I would say. And from the questions, I get that the room really get what I have to tell, and that's make me feel very good about my talk. Thank you very much to all attendees on my talk, and special thanks to Chris who helps me to hold this remotely.